All right, we're going to jump back in where we left off last time. We're talking about proportional reasoning in 6.4. And we talked about, I'll just bring one of them up, the first one, about the fact that anytime we're dealing with a word problem involving this particular concept, there will always be two quantities or two different things that we're making comparisons to. So like on this one, we were talking about his days versus his days of vacation versus his months of working compared to what he has today and what he'll have after another certain length of time later. And so it was now compared to later. And those were the two quantities that we were comparing before. We are on example 6. So we're going to flip over to that one. This one says, at Rattlesnake School, the teacher-student ratio is 1 to 30. If the school has 1,200 students, how many additional teachers must be hired to reduce the ratio to 1 to 25? So this is a really cool problem because it's not directly one step. The ones we did last Friday were all one step. You just did one piece. There was one that was a little different. This one was a little weird. But they were still just one proportion that you did to find your solution. On this one, you actually have to do more than one. So what you actually know right now is you know the ratio, 1 to 30, and you know how many students that the school has, 1,200. What is it you don't know? How many teachers they have. Could we find that out, though? We definitely could. So we're going to compare our students to teachers, or we could have done teachers on top, students on bottom, whatever. And we have, in fact, I think I will because our ratio is set up to sort of look more like that. So we have teachers compared to students, and then we have our ratio, if you will, that we were given. That's the 1 to 30 compared to the actual number. Those are the quantities that we're comparing. The ratio to the actual number of teachers to students. So my ratio is 1 to 30, like that. And then I've got an unknown number of teachers, but I know I have 1,200 students. So we're going to cross multiply. So I have 1,200 equals 30x. What would I need to do? Yep, divide by 30. So what is 1,200 divided by 30? 40. Yeah, there are currently 40 teachers. I'm going to put the word now just to remind ourselves. This is what we currently have right now. Okay, but that's, of course, not what we want to have. What we want is we want to know how many we'd need to add to this number of 40 in order to end up getting a different ratio. So all of my setup's the same, so I'm not going to write it out again, the teachers and students in ratio and actual, but the ratio I want is 1 to 25, right? And again, I don't know how many teachers that is. I'm just going to use a different variable because I don't want you to think that I've somehow reassigned x as something different or something like that. So we've got y, and we still have the same 1,200 students. So if I cross multiply, I still have my 1,200, but now it equals 25y. So I'll divide by the 25, process stays the same. And what is 1,200 divided by 25? 48. So 48 teachers are what we are desiring, right? Wanting. But what does the question actually ask us? Yeah, how many more or how many additional that we need? So I have 40, I want 48. How many more teachers do I need to hire? 8. I need to hire 8 additional. Okay. Teachers. So be careful. I know I said this last time, but be careful to answer the question that's asked because there's lots of different questions that could be asked given the information of any particular problem. All right, we have a couple more examples. One is kind of a type C question where a student is making an argument and you're trying to help her with her thought process. Mary's working with measurements, and she writes up the following proportion. 12 inches to over 1 foot equals 5 feet over 60 inches. How would you help her? So my default when I'm talking to students, and when I suggest that you talk to students, is first capitalize on what they did right. It's a good way to start a conversation, right? I agree with you about this, or you did this correctly, or way to go on doing that part. So what have they done correctly? Yeah. So if you compare just the values on a given side, the ratio is a true ratio, right? 12 inches does equal 1 foot. That's correct. And it's actually true as well that 5 feet is equal to 60 inches. So the individual ratios are correct. So that's the first thing I would talk about, is that her individual ratios are correct. Okay, so what then is not correct? Okay, so on the left-hand side, AK, we have inches over feet, and on the right side, we have feet over inches, right? So the ratios are sort of in backwards order. It's kind of like if we were looking at the last problem, one of them it says teachers to students, and the other one says students compared to teachers, right? The ratios are flip-flopped from one another, or they're reciprocals of one another. So her ratios are set up reversed, flipped, whatever language you want is okay with me, from one another. On the left, inches to feet, right, top to bottom, and on the right, feet to inches. So what would you suggest then she does to fix the problem? She can fix this by what? What would you have to do to fix the issue?
I would suggest flipping the ratio on the right side.
Okay.
So that way it lines up across the top to be 2 inches and 3 inches.
Okay, so I'm going to say a little bit differently in the last part to just talk about the lining up. So she can do this by flipping the ratio on the right and getting inches on the top, or you could be more specific and say in the numerator of both ratios. Does that make sense to everybody? And of course, there's nothing special when Izzy said that she had to flip the right one. She could have flipped the left one if she wanted to, yeah? And our language at the end would simply say that she'd be getting feet on the numerator of both sides. So that would be one way to help her to understand. Any questions on that one? All right. Last one. In light of the fact that you guys are going to be teaching at some point, and teacher-student ratios are going to be important, aren't they? They are. Amy's friend told her that the ratio of boys to girls in her class was 5 to 6. Amy was surprised that her class would have only 11 students. What would you tell her in a non-COVID normal year? Don't tell her they're all at home sick. It's not helpful. Any thoughts?
I would just explain to her that just because it says 5 to 6 doesn't mean that's the total number of students. And explain that those numbers can represent bigger numbers. And if they don't understand, you could write out like an equation, like as an example.
Okay, so let me go off of what you said and give a specific example to back up what you're describing, because you're exactly right, Brooke. So the 5 to 6 could be, it wouldn't have to be, and she could have 11 students. I mean, like, that's possible, especially if she was a special ed teacher or something like that. Some of our schools right now in the midst of COVID are smaller. I mean, like, that is a possibility. Maybe she's talking about a private school and they just have small classes. So, like, it's possible they only have 11 students. But 5 or 6 could be reduced. Maybe I want to say a reduced ratio. Let me say it that way. That's a little bit better. A reduced ratio. I'll use your example. Okay, for example, 10 to 12 would reduce to 5 to 6. And you can write them in fractions if you want to. But if it were 10 to 12, but this could then be seen as, or thought of as, 22 students. Which is probably more realistic for a typical classroom. Would it have to be 10 to 12? What would be another possibility? You could do 15 to 18, which would be 33 students. Man, that'd be big. You might be a middle school teacher then, right? You might. Some of those classes get larger. And I'm just going to put etc. But the issue is really what Brooke mentioned and what AK sort of developed bigger is that 5 over 6 or 5 to 6 could be reduced. It could have been a larger quantity to begin with that was simplified down to be expressed in a smaller form. It's interesting to note, though, if you will, that there was 11 students or maybe 22 students or maybe 33 students. So the number of students is always going to be a multiple of 11 here. Does that make sense? And that is happening because the 5 plus 6 is 11. So anytime we multiply the 5 and the 6 by 2, we multiply the resulting value to give me the 22 by 2. Okay? All right. Any other questions? All right.